Hey everyone, we are in week 3. Today we're going to be doing chapter 4, data acquisition concepts. So we have the PowerPoint that I'll go through with you guys real quick. So this is like the author PowerPoint, and then this is my PowerPoint. Some stuff is adjusted. I would recommend using mine, but I want you to have the authors just in case you want to go back. And then we have 3 study sheets. This is a pretty hefty one. So we broke it up into 3 study sheets, and then you have the quiz. This video is going to be over here. So let's jump right into it. Data acquisition concepts. So, all right. Data acquisition is the method by which the patient is scanned to obtain enough data for image reconstruction. So data acquisition is the method by which the patient is scanned. Okay. Scanning is defined as beam geometry. A little of this doesn't make sense, but these are kind of like board-like questions. So you guys want to know data acquisition is going to come up about 80 times. Scanning, you got to know that that's related to beam geometry. Okay. We're going to talk about the different generations of scanners. It's very annoying, but I do know that is on the boards. It's stupid. It sucks, but you do need to know the generations. I actually took I had to renew some of my CE points recently, and I took one of their quizzes, and they're still talking about beam generations or scanner generations. It does not make sense to me, but I guess it's important. So yeah, so pay attention to that. So the basic scheme, and then this is kind of how the study sheets look. I mean, this is more important than the PowerPoint. So 2 elements in a basic scheme for data acquisition: beam geometry and components. What is beam geometry? Beam geometry is the size, shape, and motion of the beam and its path. What are components? Components refers to those physical devices that shape and define the beam, measure its transmission through the patient, and convert the information into digital data. This is what you want to focus on. This pretty much breaks down the PowerPoint into easier, digestible things, so you're not having to go through the whole PowerPoint. This is easier for me, but I do the PowerPoint because maybe it's easier for you. I like to have everything on one page rather than have to kind of scan, one slide at a time. So I highly recommend trying this because you can compare and contrast, what's the difference between beam geometry and components and all this stuff. It's all in one place. So I'll be going through the PowerPoint, but do refer to this possibly as I go through the PowerPoint or as you do it yourself. So we talked about beam geometry and components. So you want to know these terminologies. What's array, a view, a profile, and data sample? So array is the part of the beam that falls on the detector. Okay, we have the X-rays come out of the tube, but not all of them hit the detector. So array is the part of the beam that hits the detector. A view is multiple rays. So one view is more than one ray from one translation across the object. So one view is multiple rays from one scan, from one spin, from one rotation. They call a rotation a translation. All right. So array is the part of the beam that hits the detector. A view is a collection of rays from one rotation or one translation. A profile is an electrical signal that represents a signature of attenuation generated by the detector. Don't worry about what that means, just know what it is. It's from multiple choice. And a data sample is a collection of views. So a view is a collection of rays, and a data sample is a collection of views, and just know what this definition is. Data acquisition geometries. Okay, there's 3 primary types of geometries. There's parallel beam, fan beam, and spiral or helical geometry. So scanners are categorized in basically as their evolution. They look at scanning geometry, scanning motion, and number of detectors. This is also what's referred to as generations. So generations are defined by the way it's scanning, the motion of the scan, and then the number of detectors. So here are, excuse me, all the different generations. There's 1st through 7th, and I have this sheet here was a lifesaver for me. When I went to school, I made something like this because I just did not get it. It was just too much. This kind of breaks down the key things about each one. Okay, so are we going through them now? Yep, we're going through them now. So you grab this sheet here. A CT scanner is organized based on geometry, motion, and detectors. So what's a first generation scanner? The beam geometry, so we have three things: the generation, the beam geometry, the length of the scan, and then I have some additional info and then a picture. So first generation, parallel beam geometry. The length of the scan is about 5 minutes or so. It's defined by a set of parallel rays that generate a projection profile. Okay, so the rays are parallel to one another. Translate rotate principle. What does that mean? It spins and then it moves. It spins one time and then it moves. It can't continue like to do helical, right? Pencil beam scanning. I'm sorry. Actually, this is the one that doesn't spin. This is one that just kind of goes right to left, right? The tube and the detector rotate 1 degree between translations. So this is the one where they take one scan, okay, rotate. So they take one scan like from right to left, and then it rotates 1 degree, and then it does it again, and does it again, and does it again. So you can imagine that's why it takes so long. So it can only scan one time from right to left, and then it rotates 1 degree and does it again. 1 degree and does it again. So it continues to do that until it reaches 180 degrees around the patient. That's the first generation parallel beam geometry. Fan beam geometry was second generation, 20 seconds to 3.5 minutes. That's how long the scan takes. It differed from the first generation because they had the addition of the linear detector array and multiple pencil beams. So now they had multiple beams and multiple, they had multiple beams. And because of the way that the beams were moving now, it became kind of like a fan effect, okay? So that's why it's called fan beam geometry. So here it was just kind of pencil beam, where it's just up and down like a pencil. Now it's more like a fan, okay, like a V, upside down V. Same thing, 180 degrees. Third generation also used fan beam geometry. So second and third used fan beam geometry. First generation used parallel or pencil beam geometry. So how long does the third generation take? This one takes seconds. Okay, so third generation is what you're going to see in most of your places. Okay, it's the you have the tube, the detectors, and it spins around the patient. There's obviously different different variations of it, but it goes around 360 degrees, curved detector array, continuous rotating fan beam scanning. Fourth generation is where you have the detectors are solid, they don't move, so it's a rotating fan beam within a circular detector array. The detectors do not move. I've never seen this, but I guess it's out there. This is the fourth generation. So the beam moves, or the tube moves, but the detectors do not. Also fourth generation, they have a different one that's, you need to know this. It's weird, but it's look at it in the book or in a PowerPoint, but it does a notating detector ring. Okay, it's pretty weird, but just know that we'll look at this one in the PowerPoint in a sec. Fifth generation is the electron beam CT scanner. It's not really used widely. And then sixth generation dual source, seventh generation flat panel, still in progress or whatever. So look through these, and this will kind of give you a much better idea of the generations, and it'll be much easier than trying to understand it from here. So basically, I took all these PowerPoints and put them in one chart for you. So fourth generation, you have two types. You have one where it's a rotating fan beam with circular detector array, and that is this one. And the other type, which is a weird one, is a rotating fan beam outside a notating detector array. And I think they have a picture of it. It's the weirdest thing. So this is the one that we talked about where the tube rotates and the detectors are stationary. And this is the other one. This is the rotating fan beam outside a notating detector ring. The beam is here, and then the beam is like not in the gantry, I guess. And this kind of like rotates back. The detectors move, but the beam doesn't, or something like that. Yeah, no, the tube rotates, and the detector tilts. It's weird. That's all I gotta say. I've never heard of it, never seen it outside of this book. So don't worry about it too much, but just know what they're talking about. Have an idea of it, and just know that it's fourth generation. So multi-slice CT scanners. is where you get into spiral helical geometry. Okay, this is where you can do continuous spinning. It's based on slip ring technology. Very important that you know that. This is how, how is a CT machine able to spin so many times without all the wires getting caught? That's what slip ring technology makes possible. Okay. So volume scanning is basically where it continues to scan. Cone beam, we talked about fan beam, but now once you start spinning, once you start producing multiple detectors, it turns from a fan into a cone beam. So we talked about 5th, EBCT, 6th, 7th, slip ring technology. All right, so slip ring technology is what allows for continuous gantry rotation through the elimination of long high tension cables. So this is what slip ring technology looks like. There's a design here. I don't want to worry too much about it. Just know that it's a contactless slip ring. And sorry, let's see where we stop here. All right, so with this sheet here, we stop at when we get to scanner generations. Then you go to this sheet here to talk about scanner generations, and then now we're back at slip ring technology. So advantages of slip ring: continuous rotation of the X-ray beam, faster scans and minimal inter-scan delay, capacity for continuous acquisition, and elimination of start-stop process. And then we don't have to worry about wraparound cables. This is what a real slip ring looks like. All right, X-ray components. So what are the components of the X-ray system in the CT scanner? You have the X-ray generator, the tube, the beam filter, and the collimators. And same deal, you go here. We can X out of this. You go here, and now you have them broken down real nice and easy, what each one is, what it does. So go ahead and read through these. Anode assembly. Let's see if there's anything that can get confusing that I need to go over with you guys. All right, CT detector technology. All right, so this one's done. The other one's done. All right, so now let's talk about CT detectors. Uh-oh, what happened? All right, so CT detectors. The function of the CT detector is to capture the radiation beam from the patient, convert that radiation beam into an electrical signal, and then convert that electrical signal into binary coded information. Easy, right? Characteristics of the detector. This kind of tells us just a little bit about their characteristics. Know these. Types of detectors. You have a couple different types: scintillation detectors, gas ionization chamber. Detector electronics. So you have the data acquisition system, which is composed of 3 major performing functions. It measures the transmitted radiation beam, it encodes these measurements into binary data, and then it transmits the binary data to the computer. Data acquisition sampling. Each detector samples the beam intensity incident in it. Okay, the artifacts, if there's artifacts, it may be a result of not enough samples. Okay, so data acquisition sampling we'll talk about a little bit more, but basically each detector is going to do it's going to get one scan, and if it doesn't get enough scans or enough samples, then you get some artifacts. Kind of hard to see. That's where you get your where it's kind of like what's the word, scattery or quantum model. Slice thickness is one of the factors that affects sampling information. And then Z-sharp technology is where this is. Let's see, this one I wouldn't worry about too much. Don't worry about that one. Just know what it is. So a lot of this stuff you just need to know, just like the main term. Okay, types of detectors. So you have a few different types of detectors. Go through those. Stellar, nano panel, detector based. A lot of these, again, you're never going to really see, but you just want to know what they are. And that's pretty much it. It's a lot of just definitions and going through different things. Really, the most confusing part I thought was the generations. And I think if you look at the sheet that I put together, it'll make it much less confusing. So go through that. Let me know if you guys have any questions. Take the quiz, and we'll see you guys next week. Thank you.